In example 6 and on page 64, we are required to sketch on the same set of axes the graph of y is equals to x squared open bracket 3x minus a and y is equals to b over x. And we have come across such a graph before. So this one we directly go to sketch it because we know how it behaves. That is y-axis and this is x-axis. When x is positive, any constants divided by a positive number is positive. But as x approaches infinity, then y approaches 0 because b divided by a very big number will always approach 0. So we are going to have such kind of a graph. And when x is negative, any constant divided by a negative number will always give us a negative number. And again, take care of the asymptote. This has been done or rather explained in the previous videos. It is this graph that we must take care of because it's telling us that as x multiplied by x multiplied by 3x minus a is 0, then we can say x is equals to 0 repeatedly, x is equals to 0. And if 3x minus a is 0, then we can already see that x is equals to a third a. A third a is on the positive side, so we are going to have the graph that passes through there. And let's talk about a third a being here, a third a. But we must examine the shape of the graph. So as x approaches negative infinity, let's say negative 1, y becomes, this is negative 1, substituting here, negative 1, and negative 1 times 3 becomes minus 3 minus a. Minus 3 minus a becomes minus 3 minus a, just a big negative number. So you can see minus 1 times minus 1 times another negative number. You can say y is also a negative number. So as x approaches negative infinity, you can see that y approaches negative infinity as well. As x approaches positive infinity, let's give it a value like a, assuming that it's on the right of a third a. Let's talk about a. When x is a, and x is a, meaning that 3a minus a is 2a. Of course, this is going to be 2a cubed. And because a is positive, you can see y approaches positive infinity for that matter. So if you come here, as x approaches negative infinity, y approaches negative infinity. As x approaches positive infinity, y also approaches positive infinity. So, and this one is a repeated rule, so it touches and go back. So it's going to be something like that. So this is the graph of y is equals to x squared, open bracket, 3x minus a, and this is now the graph of y is equals to b over x, including this other asymptotic graph up there. That is like part A of the question. We need now to look at part B of the question, because part B talks of state giving a reason, the number of real solutions to the equation, x squared 3x minus a minus b over x is equals to 0. If how many solutions does this equation have? But if you look at this equation, you will say it is coming from x squared 3x minus a is equals to b over x. So the two functions at this point are equal. So we are simply talking about the points of intersections. So the question basically is, how many points of intersections do we have in this graph of ours? And the answer at that point is very simple. It is we only have 2 points of intersections, and therefore we have two solutions. This is one point of intersection, and this is another point of intersection, because the question is asking us, state, giving a reason, the number of real solutions to the equation, this one, when they are equals to 0. Of course, it's when we clean it up, it gives us this equation, and this equation is one of the original equation that we had, and this is the other. So we are simply talking of the points when the equations are equal, none other than the points of intersection. So this point gives one solution, and these points give one solution. So our answer is, since they have 2 points of intersection, then this equation has 2 solutions. Since they have 2 points of intersection, the thing is, since the two graphs have 2 points of intersections, 2 points of intersection, then they have 2 solutions. Then they have 2 solutions, and that is just like it. They have 2 real solutions. All right.